Hey, sixth grade, how's it going? Hopefully you're doing well. We are back doing virtual classes. Hopefully you had a great break and everything was calm and normal and chill and enjoyable. It's good to be back after break. Today what we're going to be working on is looking at percentages. We've been working with percentages before, and I think it's just important that we revisit some of the previous concepts that we did before, and then also go more in depth on percentages, according to the book 6B that we're working on actually. This should say 6B, sorry about that. We are working on 6B, there we go. Before break, boys and girls, we were able to look at just understanding the concept of percentages, decimals, and fractions, comparing them. We were looking at, for example, expressing a percent as a decimal, and then also looking at decimals as percentages and fractions as percents, and just a whole bunch of stuff, right? So that was before break. We also looked at a evaluation. This evaluation was not graded, but it did give me an understanding of how well you understand these concepts, right? Dividing fractions by whole numbers and decimals and adding and subtracting them, multiplying and dividing them, taking a look at just more concept with percentages and a whole bunch of stuff, right? So I can tell, for example, with this one, we probably need to understand it a little bit better. There might have been some word issues with the problem, but that most kids, almost 80% of you guys know how to change a decimal to a percent. A good 52% of you know how to express 2% as a decimal. Another 37% of you thought it was 0.2, so we probably have to look at that again, that concept, and a couple other ones. But for now, we're going to be just looking at parts of a whole as a percent, and then quantities as a percentage of another. So that's actually going to be the next class on Thursday. Today, what we did was we looked at just seeing how well your break was, and then we tried to get a full number of what percentage of students really enjoyed their break, didn't really enjoy their break, or didn't really have any opinion at all. So this was relatively what we came up with the first class. I think it was sixth grade. Just look back, sixth grade B today. This was the data that we came up with today for sixth grade B, and I'm just going to represent it on the screen. We had 7 students say that they really enjoyed their break. We had about 5 students say that they enjoyed their break. And we had 2 students that say they, so-so, it was okay. We had no student that said they didn't enjoy their break whatsoever, so that was good. Now, out of those 14 kids that had voted, we can try to find a percentage of the data. How do we do that? Well, our whole number is 14. Okay, that's as many students that had voted. I think there were more kids in the class, but not everyone voted. And we can try to find the percentage of students that really like their break by converting that into a fraction, right? 7/14 of the students really liked their break. Now, how do we figure that out as a percentage? Well, like we had done before, we can compare that fraction to a number over 100. Well, how do we find this percentage then? Well, just like last time, you could cross multiply and divide. So you would take 7 times 100, which equals 700. And then you could divide by the denominator on the other side, which is 14, to try to find your percentage. Sorry about the chickens. If we take a look at this, we could take 700 divided by 14, and we get 50%. I'm sure you knew what that was even before we did the calculation, right? If we just count up the number of checks of students that voted, it was 7 out of 14, which is 15%. I'm sorry, 50%, just half of the students, right? So how do we try to figure out how many students liked their break? Well, we would do the same thing. We could compare the 5/14 to the number of the whole, or the total, which is 100%, right? 14 students was the 100% of students who voted. So we can try to figure out how many students, as a percentage, liked their break. Again, we could take 100 times 5, which is 500. And then we could take 500 divided by 14, which gives us 35.7. So approximately 36% of students liked their break. Okay? What's interesting is during class, there was a number of students who voted, and then they snuck a couple of votes on at the last minute. So I compare the number that I had originally looked at, 14, to the data that we had seen on the screen, which was actually 16 votes, which made our percentage, our full percentage at the end, more than 100%. So, for example, if I take, let me just put that percentage right here. So this was 35 or 36%, right? So this was 36%, and this was 50%. And let me just quick calculate the percentage of the two students. Let's see, we have 2 over 14, which is the same as 1 over 7, times 100 equals 14%. Okay, so this should have been just 50 plus 14 plus 36, right? We can add up all those percentages to come up with our 100%. But we had more data than what we had originally planned on using. So that actually gave us a bigger number than 100. So say I add up all these percentages, right? We have the 50% of students who really, really liked their break, plus the 36% of students who liked their break, plus the 14% of students who so-so. That's 100%, okay? However, if we have more data than what we really need, and we compare that with an inaccurate number, we're going to come up with a percentage that's actually bigger. When we added everything up in class in 6th grade B, we actually came up with 114% instead of 100%. So that is a larger number than the quantity that we had originally used. We're going to go and look at a larger percentages than 100 in a couple of exercises, probably on Thursday, I think. So don't worry about that. That was actually a really good segue into the lesson. We need to understand that when we're looking at percentages, it's a quantity of 100%, okay? So that whole quantity is always going to equal 100% unless we're comparing to a bigger quantity, okay? Let's take a look at this just so we understand this concept a little bit better with bar models. Bar models are a representation in our math book that we can use to understand numbers in more visual ways, right? You've been looking at bar models ever since 1st grade, 2nd grade, when you looked at this prime book, right? So if we look at the addition, for example, what is the whole that's represented in the bar model? 3 plus 4 equals what percent? 100%, right? 7. 7 units is equal to 100%. In other words, the whole. What about subtraction? What number is the 100%, the total represented in the bar model? Now, hopefully you didn't say 15. It's actually 18. 18 is the whole because we're subtracting 3 to get 15, right? So, again, 7 was our whole, 100% for our first bar model, and 18 is our answer for the second one. Go ahead and pause the video and try to see if you can figure out the whole represented in the multiplication and division bar models. All right, well, multiplication is pretty easy. All you just did was take 4 times 5. Our 1 unit is 5. We have 4 of them, so it would be 20 units equals 100%. And for division, it tells you right there on the screen, would be 27. Okay? Boys and girls, it's really important that we understand these concepts with the bar model because on the next couple of pages, we're going to be using bar models a lot to represent percentages. So let's do this problem together. This is not inside of your book. This is just a problem that I'd like to put for you guys so you understand this concept a little bit better, okay? If we take a look, we are going to draw the bar, which is right here. We just did that. And then we're going to label it 0% and 100%. Well, I know that 0% is nothing, right? We have not represented anything in this bar model yet, okay? But if we continue across the line, we can find different percentages that are represented in the bar model. 100% would be at the way other end. So, what about 27 and 30? How do we figure out those? Well, we're not going to come up with an exact science, but if we're going to label, for example, 30%, we could just separate this into 3 relatively equal sections, okay? And we could label this 30%. That would be the first part, right? Just this first part right here. That's approximate, just like I said before. So what about 27%? Would it be on this side of the bar model or this side of the bar model? Well, since 27 is lower or smaller than 30, we're going to want to put it on the right side. So I would say it's approximately right there. This is approximately 27%. Let me color that in red. Oops, red. Color that in red. This is approximately 27% right there. Okay. It's important that we understand bar models just because they are a really great way to represent percents and portions of the whole. Okay. Let's erase the screen and go on to another problem. Here are the answers again to that same problem. Okay. We're just going to look at one more problem, and this has everything to do with the unitary method. Okay, and you'll see this on page 11 and 12 and 13. Okay. The unitary method is a strategy in mathematics that is used so we can compare one quantity as a percentage of another quantity. It says the unitary method can be used to find 100% of an amount given a percentage of that amount. So, for example, if 10% of an amount of money is $23, then what would 100% be? We could just take 100% times 10, okay? That 10%, right, times $23 to equal $230, all right? We're going to be doing a lot of comparisons in the next couple of lessons, but this was just a taste of what we're going to be looking at for the next couple of weeks. So thanks for attending class, and we will talk to you guys soon.